calculator, what can I do? 5 to the power of x. Yes, I will do a log. Log, what's my base? 5. 90 equals x. So if you ever need to solve an exponential equation, I don't know why your laptop's open. If you ever want to solve an exponential equation, and you come to this stage, you go to logs to finish it, and you can just type this into your calculator, press log base, maths. I remember this one, log 2, 8 is always equal to 3, is the same as 2, 3 is equal to, 2 to the power 3 is equal to 8. So this is the exponent. The exponent now becomes the answer. Okay, so all of these can be rewritten. So if you have something like this, 3 to the minus 2x is equal to 0.05. Looks very complicated. If I press log base 3, 0.05 is equal to negative 2x, all of a sudden the exponent is out of the up here and is down on ground level where we like to solve it. And this will just give an answer, a decimal, and then you can just divide it by minus 2 to get it. Now what happens if we do not have a calculator? Like in the next one. So if I have 3 to the power of x is equal to 1 over 81, calculators are not allowed. It's a paper 2 question. What do? I have to know my rules of indices or exponents. I need, step 1, I need to get the same base. The same base. So the bases are usually 2, 3, 5, 7. And you can see in all these questions, this one's 3, this one's 2, this one's 5, this one's 2 or 5, we're not sure yet. This one's 2 or 5, not sure yet. So we try and get the same base. What's the base I will use here? 3. Why 3? Because I can rewrite 81 as 3 to the power of something. 3 to the power of 4, I think. 3 cubed is 27. So this can be rewritten through 1 over 3 to the power of 4. Okay, what's my next step? I don't like the fraction, so I use my rules of indices. I know a fraction can be rewritten minus 4. 1 over 3 to the 4 is 3 to the minus 4, and then x is just minus 4. So this is an equivalent statement, so we can just say, just ignore the basis to finish, that this must equal this. Let's do another one. Yeah, I can do any of them. 25 to the 4 minus x is equal to 1. C is that's calculator. So you just divide by 20 both sides and then use logs. This one, what's my base?
Your base.
Is it 20? Well, 25, 1. I want to use one of these numbers usually. Which one will I use? 5 seems logical. So I'll change this to 5. 5 squared. 4 minus x. Generally, it's going to be one of these. So you bring it down to the lowest power or lowest base you can. So something like 8, 16, 64, you can bring that down to the power of 2. 2 to the power 2. And like if it's 3, 9, 27, 81, bring it to the power of 3. 5, 25, 125, bring it to the power of 5, or base 5. So what I've done is I've changed 25 to its lowest form base with 5 squared. What will I change the 1 to? I want to get into this situation where there's just the same base on either side, and I can just say that equals that. I want to write this 5 to the power of something. What is it 5 to the power of?
What is it? Oh, I remember this. 0,
0. 0. Anything to the power of 0 is 1. And now I have something that this equals that. I can multiply this 2 in, so I get 8 minus 2x. And now this bit equals this. 8 minus 2x equals 0. And what's x going to be? X must be 4. If I add that over or subtract the 8 over either way, we get 4. I'll do one more. So this, you have to go back to your rules of indices from last year, which you may not remember. Which one would you like me to do?
F.
E or F?
F.
F, okay. For this and this, divide by 4 here first and divide by 5 here first. That's how you do that, and that makes it easier. I'll do F. 4x plus 1 multiplied by a to the power of x. Remember, you will not have a calculator for this. Which one of my bases will I use? I'm looking for one of these prime bases here. 2, yes. So I'll change, first step, convert them all to the same base. So I'm going to change them all to 2. You could use 4 if that 8 wasn't there. But usually go with the prime base so you can't divide anymore. 2 squared times x plus 1 multiplied by 2 cubed times x. And I'm going to change this to 2 squared. So I've changed each one of these numbers into 2 to the power of. And now I have the same base everywhere. I'm going to apply the 2 in here by multiplying. So that gives 2x plus 2. Remember, multiply both things by it. That gives 3x. And I don't like this down here, so how do I get it into the numerator again? 2 to the negative 2. Okay? Now I can only do this equivalent thing if there's one base on each side. There's 2 over here. That's a problem. I need to combine these 2. How do I combine? I add. When I multiply indices, I add the powers. So I have 2x plus 2 plus this one. They add. Multiplying indices, I add the powers. And that is equal to 2 minus 2. Now I have an equivalent. So I know that this equals this, and over here I have 5x plus 2, I think, if I add these, minus 2, and now I can solve it. Yeah.
Don't you 2 times 2 equals 4? Like below, like the normal numbers, like 2 times 2 equals 4. So wouldn't it be like 4 to the power of 2x plus 2?
Where's this? Here?
Above that.
Here?
Yeah, like, why don't you do 2 times 2?
This?
Yeah.
Because it's not just 2, it's 2 to the power of something. And if you remember your order of operations, you got to deal with the power before you can do the multiplication. So I'm going to stick with the powers until I do that. And I can solve this then. 5x is equal to negative 4. X is negative 4/5. So you may remember those. They were done at the unit 1 last year, so about this time last year, so a while ago. All the rules of indices. Okay, your revision is on ManageBack. It includes all that kind of stuff and quadratics and everything we've done so far. Practice test is on Monday. Start your revision now.